In this nugget, we take a look at hacking websites and web apps. This will be an overview where we'll take a look at specific details and methods that are used for this. But before we begin, we'll take a look at some kind of update things relating to the Certified Ethical Hacker exam, and I'll show you where we are in our list of exam objectives. We'll take a look also at web architecture, which is important to understand if you want to properly perform the web hacks or application hacks. The web hacks themselves, there's a number of different methods for performing these, and I'll show you some of the most common ones, as well as some of the more common web application hacks. And then in our next nugget, we'll take a look at the actual demos of how to perform some of these, but do watch this nugget because it's very important to understand the background of how those work. All right, before we get started here, let's just take a look at a few notes about where we're at in our exam objectives. If you followed the Certified Ethical Hacker series here, and all the way through from the beginning to this current point in time, then you might look at the exam objectives and say, wow, looks like we got a long ways to go, and we're already into, what, 24 videos or something like that here. So how much longer is this going to take? I mean, some of you are kind of tired of hearing my voice. And here's some hope for you. If you're tired of hearing my voice, just press the pause button for 5 minutes. And then when you resume, I'll continue on with what we're doing. See, everything up to this point has been covered in fairly close to a one-on-one or one-to-one correlation with the videos that I've already done. I'm not going to follow that same correlation all the way through the rest of this because a lot of this is consolidated and a lot of it has already been addressed. So if we take a look at an example of this, like I said, a lot of it's already been addressed. Pen testing, for example, well, that's pretty much all we've been doing the entire series. So that's really been very well addressed, and I addressed some specifics about the pen testing process in the intro. We took a look at buffer overflows a number of times because we've been using Metasploit, and that's a lot of what Metasploit does is perform some kind of a buffer overflow. I'll also address it here briefly in this particular video. We've looked at intrusion detection systems, firewalls. That's been addressed in various videos as we go. And a lot of the upcoming content in this same video will be consolidated. So if we go back to that list of exam objectives, for example, we see here that we're going to be covering, where are we at here? Hacking web servers and hacking web applications. Those are largely the same, okay? They kind of blend one into the next. And a lot of the things that we'll be hacking there will be SQL injection. So there's 3 exam objectives covered in this same video that you're about to listen to. Hacking wireless networks will be a video on its own. That one's a lot of fun. That's coming up. Again, this has already been addressed pretty much. Buffer overflow has been addressed. Cryptography will be its own video as well. And then penetration testing, we're still covering that, and we've always been covering that. So let's go ahead and move on here. And as we do, we'll take a look, first of all, at our current topic, which is hacking web servers and web applications. And that really starts with addressing web architecture itself. And in that web architecture here, we have port numbers that are going to be used. And just be aware of this. I think you already know. The first two, HTTP, which is the protocol we use in our web browsers, takes place over port 80 by default. So you can change any of these apart from defaults. But most of the time, you're going to see that on port 80. HTTPS is going to be on port 443. And if you use HTTPS, really the goal there is so that we can establish a TLS session or a transport layer security session, formerly known and still commonly known as SSL, but that's really the more accurate way to describe it, and that uses port 22. Now, the reason why that's a factor is because, again, if we take it all the way back to when we're doing our sniffing and things like this, then we know where the web servers are because we can track traffic that's taking place over port 80, for example. Then we can take a look at the way the client receives data. So, for example, if I go back to my web browser here and I type in cbtnuggets.com, then what we see happening here is this is all delivered to me. I did not input anything other than a request for the specific page itself, right? That's all done now through a GET request, all right? That was all done in GET. But the graphics, the text, the picture of our CBT Nuggets employee there, all of that is in a GET. There's also sending data with a PUT. So, for example, if we go over here and we click on Sign In or Search, you know, whatever we want to do, if we enter in our email address and password as a CBT Nuggets customer, well, that would be all in a PUT request. Now, why is that significant other than just the trivia of having to know that and impress your neighbors with your vast web architecture knowledge? Well, there's tools that can manipulate this whole process right here. You can use something like Burp. This is the Burp suite. There's a free version and a paid version. I'll show you this. There's other tools as well that can manipulate that. So when we get information from the web browser, we can manipulate what appears in the client's browser if we can intercept that somehow. And we might be able to trick the the poor unsuspecting consumer, for example, into clicking on something that they shouldn't or yielding information that they shouldn't, because we've been able to manipulate that. Or the put. This is very often what we're going to be doing by demo here coming up, where we'll be able to send information to the web browser to the web server that it did not expect, does not know how to properly interpret, and does not have proper error handling turned on. And if that's the case, it's very likely that it can dump out information that's supposed to be secret. And taking a look at the vendors of web servers here, we have a couple of primary ones. There's a lot of different ones out there. I'm not going to exhaust all of them, but Apache and Tomcat are very common, and you'll see those primarily on Linux or Unix. Okay, I'll just put Linux out here to the side, though. Now, you can still install Apache or Tomcat on any version of Windows, pretty much any current version. So I could install either one of those on Windows Server 2012 R2, for example. However, Microsoft has their own web server known as IIS. The current version that you can install, for example, on Server 2012 R2 is version 8.5. Okay, so they have a pretty good operating system there and a pretty good web server. Now, we might look at earlier versions of IIS, and it was kind of laughable how insecure it was, and it was really kind of a joke in the IT community, even before security became such a big topic the way it is right now. I will say that IIS 7, 7.5, 8, 8.5, they were actually pretty good. Okay, you're going to find some vulnerabilities every now and then. Not too bad, though. There's many potential vulnerabilities in any vendor's web server. Apache, Tomcat, IIS, they all have vulnerabilities. In fact, a lot of the hacks I'll show you coming up here really are against Apache or Tomcat servers. They're going to involve usually some kind of a malicious get or a malicious post, which is more common, and most of the time we're going to use a post in SQL injection, because we're going to send information to the web server that forces it to yield information from SQL that the designers would not intend for. And there's more here. We're just going to take a look at a lot of these by way of demo coming up. So let's take a look at some web hacks. This is not a comprehensive list, but it's a good starting point, and a lot of these will be things that I think might be important for those of you that might be test takers as well. First of all, here we have buffer overflow. Now, we've used buffer overflow a number of different times through things like Armitage or Metasploit. However, you don't really usually launch that directly against a web server. I mean, the web server is somewhere across the internet, and there's a lot of intervening network devices, firewalls, IDS, things like that, that might not directly allow you to do a buffer overflow. So how can you mitigate that? How can you change that? Well, if you can find something like a vulnerable field or where error checking has not been properly implemented, you might be able to use something like an old hack like this one. Let me show you an example. Let's just review that first of all. Let's say that we have some kind of a web service or a web application running here in memory. Okay, this is memory. And here's where the web application runs, okay? Web app, okay? And it uses a certain amount of, let's say, kilobytes in space right here, all right? Now, it may also have some in reserve right up here at the top, because the web app may need to call out more memory for a certain function that it has to perform or something like this, right? If it doesn't have all this memory in use, or if it's fully occupied, that's okay. The web app will still continue to run. Maybe it'll do something else to allocate more memory or something, right? Now, what we'll do with a buffer overflow, and this is going to vary a little bit since we're doing this over the internet or through a web browser now, is we're going to send some kind of an instruction or code or some kind of padding. Really, it's going to be shell code that is too big for this space. Okay, so let's say that we have the shell code here, and we're sending it up through. It'll look just like gobbledygook. I'll show you an example here in a minute. We'll shoot that up through this memory stack, and that's why we call this smashing the stack, as it was originally called when we first started doing this. And now it kind of ejects a lot of this so that it moves further up the memory chain here. We might lose all of this reserved space here. Now the web app itself is all the way up to the top right here. Okay, way up to the top. But now there's room down at the bottom of this stack for our shell code. And the shell code could be something that we implement an instruction with, or we add some kind of malware with, something like that. An example of that kind of shell code would be, this is kind of an old hack, but this is one that worked against IIS 5, but this kind of stuff right here that looks like just a bunch of gibberish could be shoved into that memory space, and then we would be able to exploit that. There's also directory traversal. And this is also known as the ../ because what you do is you take and you enter something like this, // for example, into a field of some kind. Maybe it's an online form that you fill out where you're supposed to put a phone number, let's say, and you would put this in instead. And usually you're going to go several different levels. What you're trying to do here is, let's say that the web server, the root of the web server itself is at, let's just call it, /web. Okay. But that's not really where that is in the file system. There might be, let's say, 5 separate subdirectories further up until you get to the root of the actual file system. And then once you get to the root, maybe you want to go back down 3 more levels until you get to, I don't know, where their scripts are stored or something like that. Okay, which are not supposed to be visible to the internet public, let's say. So what we want to do again is this is where we can view the web page. That's just, you're an average user looking at the web page. We want to go up to the root, which is 5 levels up, and then down 3 down a specific directory to the scripts folder, for example. So you might go up here, we go 1, 2, 3, 4, 5, and then we might go down 3 levels, and you can spider this if you want, or you can use other tools to find out what the directories are that you need to go to get to scripts. But let's just say that this is directory 1, and you would actually type this in directory 1 right there, directory 2, and then scripts. Okay, I'm kind of running into my other example over there. But anyway, you get the idea there. So we would enter something like this into an actual field, and what we hope would happen is it would actually review to us then, or reveal to us, a listing of the scripts or the actual content of a script. Now, a lot of web servers and IDS and other security measures will see this in a field, and they'll immediately seize on that and say, not on my web server, and they'll drop that traffic or reject it in some other way. So if you just put it in plainly like we show it right here, a lot of web servers will not allow that. However, you can obfuscate that and make it more difficult for IDS, or at least for kind of primitive IDS, by using something like Unicode directory traversal. That would be where instead of entering in the // like we see here, we would enter in the Unicode equivalent of that. And there's abundant resources you can Google for Unicode tables or something like that to find out what a dot represents. And apparently a dot would be %2e, because we have %2e, that's /, and then the %2f would be the / there. And so you can kind of craft together your own methods that way. Now, of course, one of the things you want to do in order to make sure that you don't allow for this sort of thing is that there's a number of different security measures, but one of the principal ones would be to disallow directory browsing. And then by way of example, I've just gone to a Windows Server 2012 R2 server here that has IIS running, and I've just got a default web page here. This is where the directory browsing would be configured. Now, by default on any modern web server, Apache, Tomcat, IIS, whatever, directory browsing is disabled by default. But very often what will happen is we'll have a user call in, and they'll say, hey, every time I try to click on this link that's on the home page, it just gives me a blank page, or it gives me an error message, says, directory not found, something like that. So we're trying to troubleshoot this, and especially if you're inexperienced as a IIS troubleshooter, for example, you might double click on this and you say, well, it says directory browsing is disabled. Let's try to enable that and see if that'll let them through, and then they'll take that and some other troubleshooting methods. And then once they fix the problem, they forget that they enabled directory browsing. Now, this is not a good troubleshooting method in the first place. If you're not able to get to the appropriate directory by clicking on the link, for example, in a web page, this is not your problem. However, they may have done this just to try to troubleshoot something. Well, I got to disable this before I forget myself, but you should never at least leave that on or turn it on if at all possible. The next thing we might have here would be parameter tampering or URL tampering. So, for example, if we have a banking website at http://nuggetlab.bank.com, okay, and we have an account number in here. Of course, this is all made up. Don't try to hack my account number at this account number. Anyway, so this is my to account number that I want to transfer money into. This is the account number that I want to transfer money from. And this is the amount that I want to transfer. Let's say that's $20. Well, I could change the to account to my own account, maybe the hacker's account of 57213, okay? And I can change the amount to $20. That's kind of stingy. This person's not very generous. Let's just make it $20,000. How about that? And so then I'm able to change that just by tampering with the URL. Now, you're not going to find a banking website that has this specific vulnerability. That would just be too easy, right? At least I hope so. But there are an alarming number of websites still out there that have a lot of these vulnerabilities. And a lot of the things that we're showing you here, these are actually pretty simple for an experienced web designer and web programmer. But there's too many of them out there that are still just vulnerable. There's also URL obfuscation. This can be used a couple of different ways. One would be for web hacks, like we're currently discussing. The other would be for a phishing attempt and a social engineering attack. So, for example, as a brief tangent here, let me just drag over an email. Got one here somewhere. Okay, this is actually a legitimate email. It's not phishing or spam or anything. So it's about photography, right? And I love photography. So as I was going down through here, if I were to hover over one of these links to see if it was actually a phishing attempt or something, oh, look at that. How to shoot better cat portrait photos. I've been wanting to know how to do that. Anyway, so if I hover over this, if you look down in the lower left, you'll see that it shows the link there is something like a Bonnier's Science Group and so on and so forth, right? Well, if this was actually an obfuscation attack, a URL obfuscation, if I hover over that, I'm always suspicious if I see just an IP address there instead of an actual URL, right, or actual domain in that, right? So what we might do in a phishing attempt is we might take the IP address because we haven't actually registered something. We just want people to go to that IP address. And this is especially going to be the case if it's just there temporarily for a couple of days to try to scam as many people as we can. And then what we can do now is we can convert the IP address to a binary number and then back to decimal. Let me show you how that might look. So let's just use an original IP address. And of course, this is a private IP address, but I'll just use that by way of example. If I want them to go to http://192.168.1.78, then they may be suspicious of that. Okay, so what I'll do here is I'll convert that to binary. Okay, and now in binary, if I expand this up a little bit, 192 is equivalent to these first 8 bits here. 168 right here, I can't use my mouse for some reason right now, but anyway, 168 right there is actually equivalent to all of this. 1, of course, would be this. 178 would be this. Now, so we've got all those equivalents there. Now, you can't just type that into your browser. That's not going to get you anywhere. Okay, so we're not quite done yet. What we do next is we remove all of the dots to combine it into a single 32-bit value, which is really what it is anyway. We just put the dots in there to make it easier for us humans to read. Once we take that 32-bit value, then we convert this long string of 32 bits back to decimal, and it gives us this number right here. And we could use that in URL obfuscation and put that into the link instead. By the way, you might be wondering how I was able to do all of that. People, I'm really just that smart. I was able to go through this and just look at that, and just instinctively in seconds know that actually equivocated to this. Actually, once I typed it into calculator, I was able to figure all of that out. Anyway, some of you are thinking, yeah, right, James, we know you can't even add 2 plus 2. So how were you going to do that? Anyway, so that's how we would do that sort of thing. Now that's, again, what we would do for phishing attempts if we want someone to click on a link without seeing an IP address. The other thing we could do is we could use that in a attempt to enter in a URL in a browser that takes us to a server, a web server, where it would take us to a location potentially that it would not normally allow us to access. And that's how we could also use this. Another way you could do this is, let's say that we were trying to trick people into clicking into locations that were the wrong URL. So let's say that normally we would go to cbtnuggets.com, right? Okay. Maybe we can trick this though. Maybe we would, instead of having them go to CBT Nuggets, if someone puts in a typo of CBT Nuggets, NUGETS.com, then maybe we can then hijack that session and take them wherever else we want them to go. And this will actually take them to a malicious website. Now, don't get any ideas, people. Okay? I'm just giving you an example of what other people do, not you, because you're, of course, an ethical hacker. Other web hacks that we could use would be something like just viewing the source. Now, this is not directly a hack. This is just deriving information. It could be part of your initial stages of a hack, though, because you might need to collect the appropriate information. But let's just say if I were to click on whatever this article is here, then we see how to shoot better cat portrait photos. Isn't that cute? Okay, so we see some different stuff going on down through here, and maybe we were concerned that or thought that maybe this was a poorly designed page. I actually think this one's pretty well designed, but what we could do is we could right-click on this and to view the page source. And when we do that, we see all of this kind of stuff. Now, this is a little bit painstaking because you might have to go through this a line at a time or search for key kinds of words. For example, I might look for password or PASSW or PASS or something like that. Just go down through here, and this will give me an idea for how it was developed. It might also point to directories that they don't actually want me to view or don't actually want me to go to. Ooh, this is interesting. It's probably nothing, but it got me wondering, though, at least when I saw at least this much. Anyway, so we take a look at this, and we might be able to get something useful out of that. All right, so that's part of a web hack, is actually part of performing a reconnaissance and looking for things like sensitive directories. It could also point to server names that are actually named there, or IP addresses of servers that they wouldn't want us to know about either. Again, we could also see usernames and passwords sometimes. Sometimes, especially administrators that might have gotten a little bit lazy, or web designers, they might have to put credentials in there because they're just putting notes to themselves about the credentials that are necessary to perform certain things. Also, there's passwords that we could look for there. I'm not going to really elaborate too much on these, but there's a couple of different names. THC Hydra is a cracker that you could use so that you could crack it against, for example, certain types of hashes that might appear in websites. There's also Brutus, which performs brute force hacks. Let's move on here to web application hacking, starting with SQL injection, which is the most common and successful method for web application hacking out there. Even large, well-known websites a lot of times will still inadvertently put a weakness up there for SQL injection that allows them to be compromised. Now, the way this is done is you're normally going to perform the injection in some kind of an input form, a text box, something like that. It could be, for example, an order form, a survey, a login. You could even put some of these things in the URL themselves. And there's a few different things that you could cause to happen with this. A couple of examples there would be that you could force a login without even having any credentials. So we might be able to see here coming up that there's a login attempt that I would do without even knowing the password, and yet I can still get in as maybe an administrator's account. I could drop a table. Now, this would dump out, for example, the contents of a database, and you just have to specify what data it is that you want. It could be usernames and passwords, it could be price lists, it could be any kind of information that that database actually contains. There's a number of automation tools for this. Starting from the back of this, you can use SQL Brute, Havij, SQL Ninja. Later on, we'll take a look here maybe at SQL Map, which is another method you can use for this. And what this will do is it's going to identify the vulnerabilities that are potentially there. Once it finds those vulnerabilities, then you can go through and actually perform specific SQL injection into the website that you're trying to attack. Now, as we look at other web hack applications, we look here at cross-site scripting. This is kind of weird. What happens with this is here's the attacker, and they're trying to attack this website. Here's the URL and everything up here. So they perform an attack against it using cross-site scripting. And our objective really here might not even be to destroy the website or do something malicious to the website itself. We want to make it such that it performs a vulnerability against this next user over here that also accesses the same website at the same URL. When I access it, it's fine, it's not malicious, but I plant something in there using cross-site scripting that causes something over here on this user's side to perform a malicious act. For example, it could, just perform some kind of a function other than what was intended. I mean, I'm sure that whoever the designers of the website are intended nothing malicious, but we've kind of been able to pervert that original design using cross-site scripting to give something to the user over here that might execute software or a command that the user wouldn't want installed on their computer. We can see that this will often appear where a script dynamically changes. So, for example, if we're on a website where you can register a new user account, maybe they'll give you an option for the country, and maybe we would choose the U.S. Under normal circumstances, that would give us the U.S., and then there would be a state section where we would see different states, Wyoming, Montana, Arizona, Nebraska, whatever. I don't even know if that's the abbreviation for Nebraska. Anyway, and of course also, somehow I figured out a way to make this non-alphabetical, but you get the idea here. So instead of this, if we were to do a cross-site scripting, just for proof of concept maybe, The user would choose US over here, but on the state side of things, we would now give a drop-down list for different other countries, like Germany, okay, or Yugoslavia, or something like that, which is totally inconsistent with the country that we chose. Now, this could perform a malicious act on behalf of that victim user, or we could use this further to expose something to ourselves that would not normally be exposed. For example, here we're not supposed to see that when we choose US. We might choose something else that would reveal sensitive information or something like that. Anytime you use or see less than script and then greater than tags, any tags like that, that's often going to be an indication of cross-site scripting, and you'll want to be aware of that if you're ever asked that. Okay, just be aware of that. Now, the mitigation here on the user side of things would be to disable JavaScript. That's one of the most common ways to take advantage of cross-site scripting. So disable JavaScript in the browser. They can still use Java. They can still view movies or whatever else. Java by itself is not that bad. But JavaScript could perform some kind of an executable command, for example. And that's what you don't want. If you want to make that easier, I mean, you can't go to every user's browser in your organization, but you could centrally enforce this through something like group policy object in Active Directory environments. In this nugget, we took a look at hacking websites and web applications as an overview. And before we began, we talked about where we were in the Certified Ethical Hacker exam objectives. Remember, there's really not that much left because we're going to cover a lot here in this nugget as well as the next one when I show you the demonstrations. Here we started with the web architecture so that you could have a better understanding of how some of these web hacks and application hacks actually work. The web hacks that we can use are actually sometimes alarmingly simple. It might just be using an escape attack or something like that. Pretty easy. But there's also web application hacks, which could be more complex, but which are nevertheless just as effective. And then in the next nugget, we'll take a look at the demonstrations for these hacks. Well, I hope this has been informative for you, and I'd like to thank you for viewing.